So now let's jump into some other concepts related to Python, like if, elif, and else clause, or if, elif, and else statement in Python. All these things, how do you highlight a text, or how do you make it not execute as code? All these things come under Markdown. You'll get to know all these things as you work around in Jupyter Notebook more frequently. Then if, elif, else. So as we are familiar in C, it's if, else, if, and else. So in Python, it's if, elif, and else statement. So for example, if I say, for example, let's say x is equal to 1, and I say if x is greater than 0. So that's how we type the condition. If x is greater than 0, it automatically shifts to the new indentation, as it understands that it's a new block of code, and this block of code is actually inside this upper block, so it directly shifts here. So if I say if x is greater than 0, print positive, then I go ahead and say elif it's not greater than 0, it's less than 0, print negative, right? And an else condition which will say if x is not greater than 0, neither greater than 0 nor is it less than 0, just print that it's 0. So as you can see, a single quote and double quote doesn't actually matter, both are interpreted as strings. So yeah, this is how you write if, elif, and else block in Python with a proper indentation. So if I go ahead and execute this portion, what it says is x is greater than 0, so it's positive. If I go ahead and do this, it says it's negative, and if I just put a 0, it says it's 0. So it's fairly simple how to use an if, elif, and else statement. Moving ahead, let's go to loops. So again, we have a while loop and a for loop in Python. So while loop. So while loop is as simple as it was in Python, C or C++. So while you again have to go and say I is equal to 0, while I is less than 100, print I. And as we did in C or C++, we manually have to increase the value. So one important thing in Python is that this statement doesn't work in Python. I don't know for what good reason, but you can't use that. You have to use either this or this, or as some of the smart pants would like to do, x is equal to minus 1. So yeah, all these statements work. If you don't understand this was just a joke, ignore this and do this. So what it does is it starts from 0 and goes till 100, and 100 isn't included in this, and it prints this, right? So this is how while loop works in Python. So for loops, I mostly prefer using for loops in Python because they are fairly simple. I don't have to explicitly go and put that incrementation or decrementation statement, and I mostly forget that statement. That's why I like to use for loop. So for I in range 1 to 100, or let's do similar to before, 0 to 100. So what this range function does is it loops over the values or the range that you provide it with. So from 0 to 100 will jump one step, and if I go ahead and say additionally 2 or 3, what it will do is it will just start jumping 3 positions rather than just a single position. By default it's just 1 position. So if I say print I, it will print 0, 1, 2, 3, and if I say print this, it will go ahead and jump 3 positions, 0, then 3, then 6, then 9, and like that. So that's how for loop is used in Python, as simple as that. After this, let's go ahead and try to write a function in Python. So for function, to define a function in Python, the statement or the clause, the keyword that we use is def, and then write the name of the function, and these are the arguments. You don't have to, as before, you don't have to explicitly say what the argument's data type is. I'll just say argument 1 and argument 2. That's how arguments are used. Rather than saying integer x, integer y, just put argument 1, argument 2, and you can go ahead and say the default value for this is 0, or let's say the default value is 1, similar to C++. Then let's say print arg1 plus arg2, right? So if I go ahead and execute this function with certain values, let's say 1, and I don't provide the other value for argument 2, it will print 2 because 1 is passed as argument 1, argument 2 is by default 1, 1 plus 1 is 2. If I go ahead and pass 1 plus 3, it will print 1 plus 3, 4. So that's how you define a function in Python. It's fairly simple, not much to do there. You'll learn more about defining functions and everything, and using the assert statement as we go along. As you can see, you can't explicitly write what type of data this is. So for example, if I still go ahead and do name of function, let's say I do 1, 2 and 3 comma 4 comma 5 comma 6. These are lists, so as you might not have thought, argument and argument 2 should be for integer or even for float values, but not for lists. So it will still execute 1, 2, 3, and it will add these both lists, because this is a valid operation in Python to add lists. You just say list A plus list B, so this will also get executed, but you didn't want it to get executed, so you can put down an assert statement. For example, assert type of arg1 is equal to integer. So if type of arg1 is integer, it will execute the corresponding code. If not, it will not execute the code. So if I go ahead and do this, it says that assert statement failed, and there's an assertion error that the type doesn't match which was specified. So that's how you can use these statements to actually check, provide some checks in the whatever definition, function definitions and everything. So that covers function. Other than that, there's the concept of exception handling in Python. So what is exception handling in Python? So Python basically uses this thing called as, we are familiar with try catch, right? So we here use try, except, and finally. This is the block that we use in Python rather than try catch and everything. So what this does is it goes ahead and tries to execute a particular portion of code. If this particular portion of code fails, then it goes to except. Given a particular condition, it goes to except, and then finally, doesn't matter which portion of code executes, either try portion executes or except portion executes. Let's say block, so let's say try block executes or except block executes. It doesn't matter, the portion of code that is put under finally block will definitely get executed. So let's go ahead and write try, let's say x is equal to 0, try to divide 5 by x. If it's not possible, okay, let's say print this except, what this will give is, if it's 0, it will give a 0 division error. So to know the name of the error, you can directly go ahead and try to do something like 1 divided by 0. It says 0 division error. I'll just copy this error and paste it here. So if I get an except block, except 0 division error, if 0 division error happens, except when, it basically is saying try to do this, except when you get a 0 division error, what you say is print the result is infinity, because anything divided by 0 is infinity. And finally, no matter what happens, just print divided successfully. What is the spelling? Successfully, yeah. So because x is 0, it says it's divided by 0, so it's infinity, and divided successfully. If it was, let's say 4, it would give an output of 1.25 because 5 divided by 4 is 1.25. Doesn't matter the data type. Python has its own interpretation of how to divide and to multiply even when integer value is passed. So it's saying 1.25, and no, because except portion didn't get executed, the try portion got executed, and directly the interpreter jumped to finally block, and the part of code that was under finally block gets executed, and it says divided successfully. Now let's jump into something known as classes and instances. So classes in Python is fairly simple and similar to that in C++. So class, let's say class A, we define all these things like all the variables and class variables and function under here. I'm not going to go over the concept of classes and instances. I'm just drawing similarities or whatever. Just telling you how whatever was used in C++, how those things are used and how they get their analogy here in Python. So for defining the class, we directly put class A here. So class builder here is set as define init. It is the default class builder, and for every function that you define under a class in Python, you pass the self variable. So what this self is similar to the this pointer that was used in C++. If you don't know the concept of this pointer and self, go to the book and you'll get to know what these things are. So what the self indicates is that it points to the current object of that class that is being currently accessed and executes the code for that particular object or instance, as we call it in Python. So we can go ahead and say that self.a is equal to 5, self.b is equal to 4. So what this does is it assigns the class variables a and b the value 5 and 4. If I say, for example, to initialize or instantiate, as we call it here, arg2, and if arg2 is passed to a and arg1 is passed to B. So this basically completes the basic definition of whenever a class A is instantiated. This is what these statements will be executed. So now let's go ahead and try to define a different function. Let's say print it, and what this will do is print all these values, self A and self B. So we are not going to pass any arguments, or let's say we are going to pass an argument which is called as both and true. So true and false are the boolean values in Python, like similar to the boolean values in C or C++. If I do type true, it says it's a bool. So if it's both, so let's print self.a, and if both means if both is set to, print self.b as well, right? So if I go ahead and say that instance 1 is an instance of class A with the parameters 1, 2, and then I go ahead and say instance.1, print it, right? So it's by default true, so it will print both the values. If I say both is equal to false, it will just print the above statement and not the latter statement, because both is false right now. So how do you make any variable or any function of a class public, private and protected in Python? It's as simple as if you have to make it public, don't do anything, just keep it as it is. If you have to make it protected, add an underscore before the variable name, and if you have to make it private, just put double underscore under the name. And after that, for example, let's say it's it's a private variable of the class A now. So if I go ahead and say I'm trying to access B variable, B is accessible right now. If I try to access the A variable, it says object A has no attribute A, because A is now a private variable of class A rather than being public or protected. So yeah, so inheritance in Python works fairly simple. If I say class B and put down A here, it will inherit whatever is there to inherit from class A in different ways. I'm not going into much description about these things because they are not needed right now, as they will be needed during the course. We'll discuss these things as well, but for now you can refer to the book and get a better understanding of all these things. So yeah, this brings us to the end of very first module of our course. All these topics have been discussed. Libraries, I suppose let's not discuss libraries in details here because there's not much to discuss, but let's go ahead and try to understand the syntax. For example, there's a library known as math. So if I import math and then say math dot, all these functions are available for me to use right now. So if I say import math and let's say use the cos function, cos of 45, it says 0.522, which is half, as we know. So this is one way to do it. And if I directly try to use cos right now, it says there's no function, there's nothing named as cos. So if I do from math import cos, then cos is imported. Now I can directly use cos because it says cos is a function. Cos 45 is 0.45. So I can still go ahead and do something like this. Cos as, let's call cos as THC, whatever. So now I can use cos as THC. Okay, THC. It will still give me the same result. So I can use an alias. I can directly import the whole library like we did here, or we can import a particular function from that library which is available under it, and then you use it. Or we can import and then a particular function and then name it as an alias, or I can import the whole library as an alias, mth. Now I can use mth dot. All those functions that were available as math are now available as mth as well. So yeah, this covers the basic portion of Python and introduction to this course. After this, we'll be discussing some advanced libraries and using them as we go, and we'll directly jump into tutorial for these libraries because there's not much theory to discuss in all these things. These libraries are used to visualize or perform various mathematical operations that are needed. So the math there is not what I'm going to try to teach you. How to use these libraries to perform those mathematical operations, and that visualization is what I'll be focusing on. So this brings us to the end of first module. I'll see you in the next one.